Assalamualaikum warahmatullahi wabarakatuh, and hi to our lecturer, Madam Noraini. We are going to present our video presentation for CHM 260, which is the title is HPLC method for determination of caffeine content in tea and coffee. Before we start, we are going to introduce ourselves first. Hi, my name is Muhammad Hikal bin Muhammad Rizal, and my student ID is 2022-829-622.
Hi, my name is Nur Hamizah Natasha binti Muhammad. My student ID is 2022-624-642.
Assalamualaikum and hi, my name is Walana Batrisha binti Wan Jafran and my student ID is 2022-616-742.
Hello, my name is Nusabira Najwa binti Anwar and my student ID is 2022-871632.
Introduction. Compounds in a chemical mixture can be separated using the broad analytical chemistry technique known as high performance liquid chromatography, HPLC. The HPLC works on the basis of chromatography, which involves a liquid mobile phase carrying a sample through a stationary phase. The components of the sample and the stationary and mobile phases separate as a result of their different interaction. High resolutions, accuracy, and adaptation in handling different kinds of samples are characteristic of HPLC. Its ability to analyze substances ranging from small organic molecule to large biomolecule makes it essential in a number of fields, including biotechnology, environmental analysis, food safety, and pharmaceuticals. Modern HPLC systems come with advanced detectors like mass spectrometry, fluorescence, and UV visibles. The various modern of HPLC such as reverse phase, normal phase, ion exchange, and size exclusion chromatography also expand its capabilities.
So, what their objective? Their objective are to determine the retention time of caffeine, and the second one to analyze the caffeine content in tea and coffee samples from Nepal, and the third one is to use validate method for quantifying caffeine in tea and coffee samples.
So today I'm gonna tell you about methodology. The first one is sample collection. A total of 12 CTC samples, 7 green tea and 8 medium roasted coffee bean, also 3 roasted coffee bean powder samples were collected from Nepal. Coffee and tea were kept at a room temperature. All glassware properly cleaned and rinsed with HPLC water before use. Next is a sample preparation for caffeine determination. Caffeine was extracted in water. Tea and coffee sample were first grounded to powder and 0.3 gram of grounded sample were weighed in 250 ml conical flask. Then 200 ml of distilled water was added and placed over a water bath. Extraction was done for half hour when the solution cooled. Volume maintained to 250 ml and filtered through a Wefman No. 1 filter paper. 1 ml of filtrate was piped into a clean 10 ml of volumetric flask and made to the mark with HPLC water. Prepared sample was then filtered through the microfilter and filler into HPLC vials for analysis. Next is moisture content determination. Moisture content of tea and coffee sample was determined according to AOAC 2005.
Next, the preparation of stock and working solution. It began with the formulation of a caffeine stock solution of 100 ppm. This was achieved by accurately weighing 10 mg of pure caffeine and quantitatively transferring it into 100 ml volumetric flask, followed by dilution to the mark with the mobile paste. Working standard of various concentration were then prepared through the serial dilution of the stock solution using HPLC grade water. An external calibration curve was plotted to establish the relationship between peak areas and the concentration of the standard. The caffeine content of the sample was determined by interpolation using the regression equation of the best fit line, with the result presented as a percentage on a dry basis. For statistical analysis, the results were expressed as mean plus minus standard deviation and analyzed using Microsoft Excel 2007. Additional calculations were performed using lab solution software to ensure accuracy and reliability in data handling. Next, the method evaluation process considers several key characteristics, including linearity, range, limit of detection, LOD, limit of quantification, LOQ, repeatability, and recovery. Linearity was assessed using 5 different standard caffeine solutions to evaluate the plot of signal as a function to analyze concentration. Results was tested through interday and intraday repeatability assessment. LOQ and LOD were determined based on the signal-to-noise ratio with value of 3:1 for defection and 10:1 for quantification. Recovery was tested by spiking blind sample with varying caffeine concentration and analyzing their content to confirm the method accuracy and reliability.
This is a HPLC diagram, and each component has their own functions. The first one is a HPLC solvent insoluble. So the function of this solvent is a content mobile phase, which helps in transporting the sample through the system and interacts with the sample component for separation. The second one is a HPLC pump. It delivers the mobile phase at a constant high pressure to the injector and subsequently to the column to ensure the flow rate consistent and reproducible. Third is an injector. It introduces the samples into the mobile phase stream and can be done manually or automatically using a autosampler. Fourth is a HPLC column, which this column packed with a stationary phase material. It is at the heart of the system where the separation for component in the sample occurs based on the interactions with the stationary and mobile phase. 5 is a detector. It identifies and quantifies the separated components as they elute from the column. 6 is a waste container. It collects used mobile phase and eluted sample components after passing through the detector. And the last one is a data acquisition system. It records and processes the signals from the detector to produce chromatograms, which help in the qualitative and quantitative analysis of the sample component. HPLC setting of the experiment, which is the instrumentation. HPLC model 1514, which is Shimazu Corporation. Zorba Eclipse plus 18C column. Pore size, which is 5 micro, internal diameter, which is 4.6 nanometer, and length 150 nanometer. Reverse phase with ODS. Flow rate at 1 ml over 1 minute, and this rate is a constant. Column temperature at 40 Celsius. UV detector set at 275 nanometer. Mobile phase, which is water and methanol, and the rate is 60/40. Both are HPLC grade. Sample injection volume is 10 microliter.
Now I will analyze the results. First, to point out the range of tea and coffee products available, a study examined 5 standard caffeine solution concentration ranging from 2 to 10 ppm. The calibration graph showed a linear relationship between the concentration of caffeine and the measured signal, with a strong positive correlation between the concentrations of 2 and 10 microgram per milliliter, with an R-squared value of 0.9928. Next, for method repeatability analysis, analyze the same standard solution 6 times on various days. The results showed a satisfactory percent RSD for retention time and area. The findings are provided in table 1 and 2. In table 1, which is intraday repeatability for 10 ppm, showed the percentage RSD for peak area is 1.1428, and the percent RSD for retention time is 0.903 minute. In the table 2, which is interday repeatability for 10 ppm, it shows the percentage RSD for peak area is 1.464208. The percentage RSD for retention time is 1.635 minute. Besides, for method sensitivity measurement, for standard caffeine concentration of 0.2 ppm, the instrumental program measured 3:1 signal to noise ratio. The LOQ was found to be a 0.7 ppm based on a signal to noise ratio of 10:1. The second one is method accuracy. To determine technique accuracy, spike blend samples at standard concentration 1, 5 and 10 ppm. The results show the recovery percent of caffeine is more than 97.6%. Last but not least, caffeine content analysis in tea and coffee. Caffeine content of tea and coffee samples were analyzed, converted into a percentage dry basis for the study. The caffeine concentration of tea and coffee was found to be at least 2 and 1% respectively.
We move to discussion. Caffeine is efficiently separated from other substances using HPLC with a river phase column and a methanol water mobile phase 40 to 60. The UV detector at 275 nanometer has a strong absorbance at this wavelength, which confirms accurate caffeine detection. HPLC offer quick and accurate caffeine analysis with a retention time of only 2.6 minutes, which makes it perfect for regular quality control. For qualitative analysis, caffeine is extracted with water, filtered and prepared for HPLC analysis. A standard caffeine solution is injected into the HPLC system alongside the sample under identical conditions. The sample's retention time is compared with the standard to confirm the presence of caffeine. And for quantitative analysis, to generate a calibration curve, inject standard caffeine solutions into an HPLC and plot the peak areas against known concentrations. Using the calibration curve, calculate the caffeine concentration and after accounting for sample weight and dilution, express it as a percentage on a dry basis.
To conclude, the validated HPLC UV method has been demonstrated to effectively determine caffeine content in tea and coffee. This method ensures accuracy, reliability and reproducibility, as evident by a relative standard deviation of less than 2%. Given its precision and efficiency, we recommend this method for routine caffeine analysis in beverage, making it an excellent choice for both quality control and research purposes.
And this is our reference. Thanks for watching.